Hey guys, and welcome to my crash course for Pandas. Now Pandas is a library for Python that is used for data analysis and data manipulation. It's one of the most used libraries in the data science community, and today my goal is to teach you as much as possible about Pandas in as little time as possible. So Pandas is known for its data frame data structure. You can think of a data frame as like an Excel spreadsheet with rows and columns and data being placed in those cells. Now Pandas also has another data structure known as the series. A series is basically just a one-dimensional array with index labels. So you can think of it as one column of a data frame. So to get started, we're going to have to install a few Python modules. You will need access to the pip command. So if you don't have the pip command installed, you will have to install pip to continue with this tutorial. So the first one we're going to say pip install pandas. You can see I already have pandas installed. We're also going to need pip install yfinance to get our data. So once that is all installed, we're going to first import pandas as pd. Then we're also going to import yfinance as yf. And then we're going to define some variables. So the company we're going to download data for is Tesla. Start date is going to be, I'm going to make it 2001, so the 1st of January 2000, and the end date I'm going to make it the 31st of December 2022. Now to get our data frame, we're going to say df equals yf.download and then company start and end. And if I just print it out like that, df is just going to return our data frame and show it to us in this Jupyter notebook. Now if you guys are not using Jupyter notebooks and you're using an IDE like PyCharm or VS Code, you will need to print the df. That will look slightly different, but just for the rest of the tutorial I'm not going to use the print command. So wherever you see me using the word df or just like typing the variable name, that also goes for the other stuff we're going to look at like iloc. You guys will have to say print. But anyway, here you can see the data. You can see we have these columns: open, high, low, close, adjusted, close, and volume. And we also have the date column, which is like on a different level. That is because this is our index column. Now I actually don't want the time zone to be here. You can see this -4 and the -5. So to remove that, I'm just going to copy in some code. You guys can pause the video and type that in. So then your data frame should look like this. Now you can see the date is in a much more readable format. Now another very important feature of Pandas we're going to make use of is the save function. So we're going to save our data frame as a CSV file. Now to do that, you simply type df.to_csv and then you define a name. I'm going to call mine tesla.csv. And if you run that, you should see a tesla.csv file in your directory. Now, how do we load from a CSV file? We can say df equals pd.read_csv and then just give the path, keep typing that wrong, then just give the path to your file where the data is saved. And if I print this, you can see here's our data frame, but can you notice that something's a little different now? Our date is no longer the index. So to make the date the index column when reading a CSV file, we just add another argument here and say index_col equals date. There's also another way to do that. You can say df equals df.set_index and then type in like that. Notice how we set the data frame to df.setIndex. So df.setIndex is not going to update the data frame. It's only going to return an updated data frame. If you want to do it in place, you can just add another argument, in place equals true, and that will give us the same result. However, the convention is to not use in place equals true. So next up, we're going to look at the head and tail functions. So df.head is going to give you the first 5 rows. You can also add a number in here. If you want the first 10 rows, you can say df.head with 10 in there. And tail works exactly the same. It's just going to give you the bottom 10 rows. Next, we're going to look at iloc and loc. So df.loc is going to return us a subset of the data frame. So if we want the first row, we can just type in the index like this, if I can type, There you can see we get the data for this first row. You can also get a slice by defining a start and an end point split by a colon. So we're going to go to the 23rd of December, so 2022-12-23, and that's going to give us this nice subset of the data frame. What if we only want the closed column? Well, you can say comma, and now you define the column, and that will give you only the closed column for this subset. You can also leave this blank and just put a colon in the row section, and that will give you the closed column. More on accessing columns later. Now the iloc attribute works pretty much the same way as loc. It's only going to work with numerical values. So if we want the first row, we can put a 0 in there. Note it's not 1, it's 0. 1 will actually give you the second row. Notice here that the 1.7193 is the second row. If we want the last row, it's going to be -1. Second last row, -2. And don't get confused with this data. This is not the full data frame, this is only the head. So maybe I should actually just print out the data frame like this. Here you can see we have the second last row. Similarly, we can also do a slice. So if we want the 23rd up to the 31st row, we can do it as such. We can also leave one of the arguments blank to basically say we want from 23rd to the end, or we want only the last 20 entries. And this also works for loc. So now that we know how to access subsets of the data frame, we will also be able to access individual cells. So let's go back to the loc quickly. I want the low of the 6th of December. So to do that, I can just type 2022 December 6, and then comma, and then low. And that will give us the low value on that date. Let's try getting the volume on the 29th of June 2010. There you can see, here's that value. And of course, iloc still works the same. So first row, and we want the 1, 2, 3, 4, 5, 6, so number 5, column number 5. So another way you can access a column is by just specifying the column name in square brackets like this. This will print out the volume column. There's also a third way to access the volume column, but this is really not advised. I don't advise using this. You can say df.volume. So with this newfound knowledge about columns, let's create a new column. So I'm going to create a column called range, and I'm going to set this equal to the high column minus the low column. And if we print the data frame, you can see we have this range column added, and that is just the high minus the low. What if we want the change from yesterday to today? Well, we can add another column to show yesterday's value. And to get this, we're going to use the shift function. So df dot, we're going to use the closing price dot shift, and to shift the close column down, we're going to use a positive value of 1. So if I print this out, you can see that now we've shifted the close column down and put it in a new column called yesterday. Note that our first value will be not a number because there is no row before that. So to get the change, we can then just make a new column called change and set that equal to the closing price minus the yesterday column. But you guys can probably notice that this yesterday column is redundant. We don't actually need it. We can just do the following and get rid of it, and it will give us the same answer. But now we still have this yesterday column. So how do we get rid of it? Well, we can say df equals df.drop, and we're going to say yesterday is the column we want to drop, and because we're dropping a column and not a row, we're going to use access 1. Oops, that should not be a square bracket. There we go. Now we can see we dropped the yesterday column. I think access 0 is the default, and that is for dropping rows, but in this case we're dropping a column, hence using access equals 1. Now you can also use df.drop in place equals true, but once again, in place is not the industry standard. It is advised to set your data frame equal to whatever this returns. There's actually an easier way to get this change, so we can do that by using the diff function. So let's make a df change and set this equal to the closing column dot diff, and we want the difference from one row above. And if you print this out, still the same answer. If you want it in percentage form, we can just copy this, say percentage change, And now you're going to say pct underscore change. Now for all your statisticians out there, you probably want to calculate the minimum, maximum, mean, standard deviation, all those stuff. So how do we get the mean of the closing prices? Well, we can say mean equals df close dot mean. And if we print this out, it will give us the mean price of the closing column. This also works for max, min, and standard deviation is std. Don't know why they chose that as the name. Okay, so now we know how to calculate the mean, but what if we want a moving average? So let's say we want the average for the last 20 days and not the whole column. Well, we're going to do that by using the rolling function. So df ma20d, that's what I'm going to call my column. I'm going to say df dot, use the closing column again, dot rolling. We're going to roll the last 20. So this is just going to return for the current row the last 20 entries. It's a little confusing at first, but once you get used to it, it makes a lot of sense. So if I just do this and print the data frame, this will give us the 20-day moving average. You can also do it with the max, the minimum, and the standard deviation. And if you want, you can also use sum to get the sum of the rolling window. Another function that's similar to rolling would be expanding. So what if we want to calculate a rolling total, or cumulative total? So I'm going to call mine cumulative total, and instead of using rolling, we're going to use expanding. So this is going to be an expanding window, and expanding doesn't actually take a parameter. If you want, you can put in a minimum. So you see when we add 20 in there, it gave us some not a numbers, but this will give you the cumulative total for the closing column. So as a data scientist, you also need to be able to filter your data. So to do that, we're going to return to that loc attribute. So I'm going to create a new data frame, df underscore fill. I'm going to set that equal to df.loc. And our condition is going to be, we want to filter for wherever the stock closed higher than it opened. So wherever the closing column is greater than the open. So df.close is greater than df open. Pretty straightforward. There we go. And if we print this out, this will only give us the rows where the closing price is greater than the open. So now we filtered our data. We probably want to run this through some program and do some further analysis with it, but you can see that we still have some not numbers in here, and that can cause some issues. So how do we get rid of these? Well, there are a few options. We're going to look at two of them. So first off, we can just drop them. So get rid of those rows. So to do that, you can say df equals df.drop NA. And if we print this, you can see that those values no longer appear. So I just realized that I dropped all my NAs. Now I can't replace them. I should have used a different variable name for this data frame. But let's just calculate another moving average quickly. So there we go. Looks like we got some error here. Not too worried about that. But see, we have some not the numbers again. So the second way to deal with them is to say df equals df.fill NA. This is going to replace them. What do we want to fill it? Let's just say Missouri. If we print it out, we've now filled those cells with that value. So the second last thing we're going to look at is looping through your data frame. So if you want to loop through your data frame programmatically, you can do it as follows. Now just keep in mind that Pandas is very well written. It's written so that all these columns are vectorized. So when you want to add another column and like perform operations like we've done now, Pandas is very good at dealing with it. So you want to minimize doing stuff manually. But if you have to loop through your data frame, this is how you would do it. So I don't want to loop through this entire data frame because we're going to print stuff. So I'm just going to create a counter, set that equal to 0. And now to start the loop, we're going to say for index, comma, row in df.iterRows. So this is going to enumerate over our rows. It's going to give us the index and the actual row itself. So print index. So let's actually also print something from the row. So let's print the high value and then say counter plus 1, and if counter is greater than 10 break. So let's run this. So as you can see, this is giving us the index and the high value for the first 10 rows. That's how you loop through a data frame. And then the last thing we're going to look at is how do we transpose a data frame. So transpose is when you flip the x and the y axis. Very simple. The shortest attribute ever. It is literally one letter, df dot capital T. And if we print this out, now you can see we flipped the columns and the rows. So please like and subscribe if you guys liked the video and would like to see more. And I will see you guys in the next one. Goodbye.